Right, so Math 1100, it's 2023 exam. Number one here, use the laws of algebra of sets to simplify the following expressions involving sets. Okay, so starting with the first one, we want to simplify a minus b minus a. Now, when you are simplifying sets, what you need to have in mind is that the same letter should not be seen twice. So what I'm going to do here is, so this will become a, where there was this minus, the first minus, I'm going to put intersection. Remember, a minus means a intersection complement. So put the complement outside here, right? Because of this first minus, the big minus there. And then now what is inside, I write as b. Instead of minus a, I'll say intersection a complement because that's the meaning. And then I'll distribute now the complement that is outside. So that becomes B complement. This will be an union. A complement, if it receives another complement, it becomes A. The sign you've seen it changes. That is according to De Morgan's law. At this point, of course, if I want, I can distribute the A complement, but that's not necessary. Just look at B complement. The easiest you can do this is try to make a simple sketching, meaning that if you can't shade, it will be hard. B complement union A means everything outside B, everything outside B, everything outside B. Union A means together with A, meaning shade the entire set A. So that is the entire set A there. We want where this shaded part is intersecting with A. Where is it meeting with A? You can see it will just be the set A itself. That is where these two parts are meeting, meaning that the final answer is just A. Wheresoever that we are going to leave this one apart from A to not be fully correct. So they'll just give you 1 mark for that 2 marks. Or some would actually give you 0. Okay, the second one, we want to simplify. Please be very, very free to ask if you have got any question at any point as we are talking. We want to simplify A intersect B complement union A minus B complement. So first thing first, I'm going to distribute the complement that is outside here to the inside. So I'm going to have A intersect B. So the second complement with the complement that is outside, if I distribute, they will cancel, because if you have got two complements, they cancel. According to De Morgan's law, the sign changes here into intersect, and then you are going to have A minus B, but we know A minus B is the same as A intersect B with a complement, right? So A intersect B with a complement, and then remember we've distributed this complement, so it will gain another complement outside here. And then this gives us A intersection B intersection. We distribute the complement outside, so we're going to have A complement union B, like that. So we can, how do I simplify this? I can't see the same letter twice, then I've not simplified. So I can just make a shading of the diagram. Set A, set B. So for set A, okay, we can see if we start with A intersection B. Let me use another color. A intersection B, I can put it in green there. That is A intersection B. And then we want also to shade A complement union B. Now A complement union B means everything outside A, as you can see, we want where and B. A complement union B means everything outside A and B. So meaning also shade the entire of set B. So if you shade the set B, now we want where these two are meeting. So look at where the green shading is intersecting with the blue one. It's actually just A intersection B. In other words, A intersection B is a smaller set in comparison to A complement union B. Every time you're having two sets intersecting, you always get the smaller set. So that is it for this one. Okay, now question B. The equation 4x squared plus 8x minus 1 is equal to 0 as roots alpha and beta. We want the first one to find the value of alpha cubed beta plus alpha beta cubed, and also alpha cubed beta times alpha. Okay, so let's start first with alpha cubed beta plus alpha beta cubed. The way we can answer this one is, let's factorize out what's common. We have got alpha and beta as a common term. So if I factorize out alpha and beta from here, we had alpha cubed, so we'll just remain with alpha squared. We'll not have any beta. On the second part, we had beta cubed, so we're going to have beta squared, will not have any alpha. At this point, we need again to factorize. Why are we even doing all these factorizations? So the thing is, you should be able to know what alpha plus beta is. And alpha plus beta is found by anyone who knows. If you've not forgotten, you need to know alpha plus beta and alpha times beta. Do we remember how do you find alpha times beta? And then alpha plus beta. Okay. Which one is C over A? Very good. C over A, and then alpha plus beta. Good. Negative B over A. So we'll go here. Our B is 8. Our C is 1. And negative 1, I mean. So I need to be negative 1 over A is 4. And then this side we are going to have negative 8 over 4, which is basically negative 2. So your aim is you want this expression which they've given you to be at least as a sum alpha plus beta or as a product alpha times beta. Anything else, you can't work it out. Now, alpha squared plus beta squared is not the same as alpha plus beta. I know others might say, okay, alpha squared plus beta squared is the same as alpha plus others. Okay, let me mention that because those are the common mistakes that people make and end up getting this wrong. Alpha squared plus beta squared is not the same as alpha plus beta squared. These two are not the same. Okay, hope you take note of that. A lot of people don't even know which one means the difference of two squares. Just like alpha squared minus beta squared. This is not a difference of two squares. This is a difference of two squares, yeah? It is, you can write it as alpha plus beta and then alpha minus beta. It is not the same as alpha minus beta squared. This is not a difference of two squares. This is alpha minus beta, alpha minus beta. So if you don't differentiate these two, a lot, trust me, have problems with this and they end up writing something else. Okay. So then we need to know, since alpha squared plus beta squared is not known, and we need to make sure that it is either a sum of alpha and beta or a product. What should we do? It is very easy. You use the same one, alpha plus beta in brackets, if it is squared. Alpha plus beta in brackets squared, you can expand this. When you expand, you are going to get alpha squared plus 2 alpha beta plus beta squared. You can write this thing twice and then start crossing and multiplying. Now I'm going to put the alpha squared and the beta squared together. I'll take the 2 alpha beta the other side. So this means that, so we're going to have alpha beta, or write a bracket. This means that alpha plus beta squared is the same as, I'll get this one, alpha plus beta in brackets squared, and then I'll take this minus 2 alpha beta the other side, minus 2 alpha beta. Okay, so what is in the brackets here is the same as alpha squared plus beta squared. Someone doesn't know that, they will never answer this question. So it is at this point now you start making your substitutions. Alpha beta, we've seen that is negative 1 over 4. And then alpha plus beta, we have seen that is a negative 2. But remember, this is alpha plus beta squared. And then minus 2. Alpha beta is negative 1 over 4. So this gives us negative 1 over 4. Negative 2 squared is a 4. Negative 2 times negative 1 over 4. That will be positive 1 over 2. And this, let me write it here, is going to give us negative 1 over 4. 4 plus half is 4 and a half, which is basically 9 over 2. Can multiply this and that will give us negative 9 over 8. So this is the sum of the two roots. Okay, this is the sum of the two roots. Let me write it on top here. Let me just say sum. Hope you understand. Anyway, I'll write it the same way it has been given. Alpha cubed beta plus alpha beta cubed is negative 9 over 8. The next one we want to find is a product, and it has already been given there. Alpha cubed beta multiplied by alpha beta cubed. You can open your mic in case you have got a question and then be able to ask as we move on. So if I move on from a question, you'll not be able to ask because I can't come back to it. When we are on it and you have got a question, be free. So we are finding now alpha cubed beta multiplied by alpha beta cubed. Here again, let me factorize. Okay. This one actually, before even factorizing, is the same as alpha to the power 4 beta to the power 4, because alpha cubed times alpha, that would be the thing. And this is the same as alpha beta raised to the power 4. But we know what alpha beta is, negative 1 over 4. And this is raised to the power 4. Meaning that this is going to be negative 1 to the power 4 is positive 1. 4 to the power 4, 4 times 4 is 16. And then we have got 16 times 16. This is what? 6 times 6 is 36. 6 remainder 3. 6 plus a 3, that is going to be a 9. This is going to be a 6, a 1. So this is 6. This is a 5. So that is 256. The next question is saying find the equation whose roots are these two, alpha cubed beta and alpha beta cubed. When you are finding the roots, how you find it is, when you are finding the equation, x squared minus sum of the roots multiplied by x plus product of the roots is equal to 0. So this will be x squared minus sum of the roots. The sum was this one. The two roots, when we added, we got negative 9 over 8. But negative as the sum with this negative, which is part of the equation, it will become positive 9 over 8x. And then the product of the two roots, we found 1 over 256. And this is going to be equal to 0. So this is going to be the equation. I can see a hand. Is that a question or it is a mistake? Okay. So go to the next question here. Is a question? Okay. Given that square root of 2 is irrational, show that square root of 2 plus 3 is irrational. You use the contradiction method. The first thing is assume that what you've been given, square root of 2 plus 3, is rational. Okay? Every time something is rational, it means that square root of 2 plus 3 can be written in the form a over b, where a and b are integers in their simplest form. We also call them co-primes, meaning that two numbers which cannot be divided by the same number, and b with that number in the denominator can't be equal to 0. So take 3 the other side, that will be square root of 2 is equal to a over b minus 3. Merge as a single fraction. That will be a minus 3b over b. Now remember, a and b are integers. 3 is also an integer. When you multiply 3 times b, when you multiply two integers, the answer is an integer. When you subtract two integers, for example, 2 minus 4, 2 minus 5, 7 minus negative 20, as long as you subtract two integers, the answer is always an integer. And an integer over an integer, the answer is rational. Now you know that they've given that square root of 2 is irrational. And then the other side, we know that it is rational because integer over integer is rational. An irrational number can't be equal to a rational number. Therefore, square root of 2 plus 3 is irrational. Okay, just like that. Make sure that you make that last conclusion, the last statement, as you write. Since the right hand side is rational, a rational number cannot be equal to a rational number. Therefore, square root of 2 plus 3 is rational. Irrational. Express 0.0810, and here 8, 1 and 0 are repeating. You want to express it as a fraction. First thing first, let x be equal to this number, and this will be the first equation. The next thing, make sure that the decimal goes in front of the number that is repeating. The numbers we're repeating is 810. The number should come in front of 8. So we are going to multiply equation 1 by a 10 because the decimal should only move once. So x times 10, that will be 10x. 0.0810 times 10, that will just be 0.810. So be equation 2. You can see the decimal has moved all the way from here and it has come here. After then, now you want to make sure that the decimal goes behind the last number repeating. So the decimal point should go behind 0. So we're going to multiply equation 2 because there are 3 decimal places here, so multiply by 1000. So 10x times 1000, that is a 10,000x, and that will be equal to, we're going to have 1 h10. So the decimal now comes here. Because 810, those numbers are repeating, just write them again. 810 with a dash on top. So the next thing is we want to subtract the two numbers where one is behind the number repeating, the other one, the decimal, is in front of the number that is repeating. That is what you want to do. Okay, so that is going to be 10,000 x is equal to 810.810 repeating, and then we have got 10x is equal to 0.810 repeating. So these two numbers are the ones that you are subtracting. So when you subtract 10,000x minus 10, it's going to give you like 0 minus 0 there is 0. So we remove a 1 from this 10 to remain a 9. We'll bring it here, it will become 10. We remove a 1, it remains a 9. Put it here, becomes a 10. So 10 minus 1 is a 9, and then you have got other 9. So it will be 9990x, and that will be equal to, now these two numbers when you're subtracting, the number at the end, you can see they are both having 0 point, they are both having 0.810. So the 0.810 and the 0.810 cancel, so we'll just remain with the h10 minus 0, which is h10. And then at this point now we divide both sides, so it will be 81 over 999, because this 0 will cancel with this 0. Okay, so this is what you want to divide. Now I just want to make sure that you see if you have got any number that can go into your two numbers without leaving any remainder, so that you express it in the simplest form. So in the simplest form, this number will be 3 over 37. So x is going to be 3 over 37. Simplify. 3 minus 2 square root of 2 divided by square root of 2 minus 1. You've been dealing with this a lot. So I'm multiplying on top and down by the conjugate of the denominator by square root of 2 plus 1. Also down by square root of 2 plus 1. Okay. So this gives you 3 times square root of 2. That would be 3 square root of 2. 3 times 1, that is going to be 3. Negative 2 square root of 2 times square root of 2, that will be negative 2. But when this root and this root multiply, because what you want to do is this number in front, which is negative 2, multiply with the number in front here, which is a 1. So negative 2 times 1, that will be negative 2. And then root 2 times root 2, that will give you just a 2. Because we're supposed to multiply the numbers inside the roots together. So 2 times 2 will be 4. Square root of 4 is a 2. And then now the negative 2 square root of 2 times 1, that would be same, negative 2 square root of 2. For thirds, when you're multiplying a number by its conjugate, just get the first number squared. So root 2 squared is a 2, minus 1 squared is a 1. Please, you always put a minus on the middle. For complex numbers, you always put a plus on the middle. That will waste a lot of your time instead of you again going, you start multiplying and everything like that. You want to add like terms. 2 times 2 is a 4. 3 minus 4 is negative 1. So 3 square root of 2 minus 2 square root of 2. Just subtract the numbers in front of the root. 3 minus 2, that is a 1. And then put a root 2. So 1 root 2, which is just root 2. In the geometry, I've got 2 minus 1, which is a 1. So it will not affect anything. So this is the form in which we're going to write. And then the second part is saying want to solve the equation. Square root of absolute value of 3x minus 5 is equal to 11 minus x. Absolute value means positive or negative. So if I put positive or negative, the absolute goes. So it will be 3x minus 5 is equal to 11 minus x. I'll get first the positive form. 3x minus 5 is equal to 11 minus x. I'll take the x this side, so it becomes 3x plus x, that will be 4x. I'll take 5 the other side. 11 minus 5 is that a 6. Divide both sides by 4x is going to be 3 over 2. I took the positive part and then I'll take the negative. So negative times 3x, that will be negative 3x. Negative times 5, that will be positive 5. And that will be equal to 11 minus x. Still take the x the other side, it becomes negative 3 plus x. That will be negative 2x. Take 5 the other side, 11 minus 5. That is going to be, okay, did I even do what was right? Okay, so for the first one, this 5 was negative. If it went the other side, it became positive. So this should have been a 16. So the answer here should be a 4. It is this one where the 5 goes the other side, it becomes negative. So we get now 6. Then divide both sides by negative 2. So it will give us a negative 3. So that is it. But for absolute value functions, make sure that your values you found are solutions. So you need to check. So when x is equal to 4, go in the original function, absolute value of 3 times 4, we know is a 12. 12 minus 5 is that a 7. So I've got absolute value of 7. It should be the same as, here I've got 11 minus 4. Absolute value of 7 is a 7. And 7 is equal to 7. So meaning that 4 is a solution. Try negative 3, go in the actual function. 3 times negative 3 is a negative 9. Negative 9 minus 5, negative 14. Absolute value of negative 14 is equal to, here I've got to have 11 minus, where there is x, you are putting negative 3. Okay. Absolute value of negative 14 is 14. 11 minus negative 3 is also 14. So this is also a solution. Okay, so both answers are solutions. Just take note, it's not always that both answers will be solutions. That's why you check. Write 4 plus 5i plus 2i to the power 3 divided by 2 plus I to the power 2 in the form a plus ib. Now let me first ask, what is I to the power 2? Anyone? What is I to the power 2? Negative 1. Good. So meaning if I multiply the entire of this function by I, it will be I times I to the power 2, that becomes I to the power 3. Then I times negative 1 is negative I, meaning that I to the power 3 is the same as negative I. Okay, so meaning that this is 4 plus 5I plus 2, where there's I to the power 3, we just put I because negative I actually, so because they're the same. So this number here will become negative. In the denominator, 2 plus I squared, just get the first number, 2 square it, that gives you 4. Get the power 2, distribute, multiply with everything inside, that will give you 4I. And then get the last number, which is I squared, that will give you I squared. If you want, write it twice and then you start crossing and multiplying. So this is going to give us 4. 3I minus 2I is I over I squared is a negative 1. So 4 minus 1 is a 3. 3 plus 4I. And then now conjugate. Multiply on top by 3 minus 4I. You are just changing the sign of the imaginary part. 4 times the 3 is a 12. 4 times negative 4I is negative 16I. I times 3 is 3I. I times negative 4I is negative 4I squared. When you are multiplying a complex number is conjugate, get the first number, you square it, always add. Get the number in front of I. Whether it's negative or positive, square it. Because whether you square a negative or a positive, it will always be positive. So this is going to give us, now negative 4I squared, you know that I squared is negative 1. So this is positive 4. 4 plus 12, that is going to be positive 16. Negative 16I plus the 3I, that will give us a negative 13I. In the denominator, we are having 3 squared, which is 9. 4 squared is 16. So that is a 25. So this is going to be 16 over 25 minus 13 over 25I. Remember the question is saying leave in the form a plus ib. So if you leave it like this, you've not left it in that form. Solve the equation z squared is equal to I, where z is x plus iy. This was an interesting question. So we'll substitute where there is z, or replace with what we have, x plus iy. So this becomes x plus iy squared is equal to I. Now we know we can expand this. How? Get the first number squared, so it becomes x squared. Get the power 2, multiply with everything inside, that will be 2xyi. And then get the iy squared, that will give us I squared, y squared, and this is going to be equal to I. Now we know that I squared is negative 1, so that will be negative y squared. Anything that doesn't have I, will put them together, so that will be x squared minus y squared is plus 2xyi is equal to I. Now we'll be comparing the coefficients on the left hand side with the right hand side. Y doesn't have any I here, which is x squared minus y squared, should be equal to what doesn't have any I this side. Now we don't have any term, meaning that we only have a 0 there. And then the number in front of I, which is 2xy, should be the number equal to the number in front of I, the other side, which is a 1. I can make x substitute the formula, so it will be 1 over 2y. And then I'll come here, where there is x, I'll put 1 over 2y. This is raised to the power 2 minus y squared, and that will be equal to 0. So this is what we are supposed to simplify what you've been given there. So what you're supposed to simplify further. So we'll distribute the square. So 1 squared would just be 1. 2y squared would be 4y squared. And then minus y squared is equal to 0. At this point, I want to find the value of y, but the way it is going to be tricky. So I'll substitute where there is y squared. Let me substitute any letter. So let me say let b be equal to y squared. So it becomes 1 over 4. Where there is y squared, I'll put b. Minus where there is y squared, I'll put b. And that will be equal to 0. For me to do away with the fraction, I'll multiply everything with 4b. 1 over 4b times 4b will just be 1. B times 4b, that will be 4b squared. That will be equal to 0. Take the 4b squared the other side. 4b squared is going to be equal to 1. Divide by 4, b squared is 1 over 4. Square root both sides, we're going to find that b is equal to square root of 1 is 1, square root of 4 is a 2. Or b is equal to negative 1 over 2. Remember, square root can give you positive or negative. But our aim is not finding the value for b. Our aim was to find the value for y. So we'll come back here. But y squared is equal to b. So y squared is going to be equal to, where there is b, I'll put 1 over 2. I need to find the value of y, so I need to square root both sides. So y will be square root of 1 is 1. Square root of 2 is just square root of 2. Or y is equal to negative 1 over square root of 2. Remember, if you square root both sides, square root is either positive or negative. I will not use this value here. Why? Because if I say y squared is equal to negative 1 over 2, and then I want to square root both sides, we know we don't have a square root of a negative number to give us a complex number. So these are the two values of y. To find the value of x, I'll say when y is equal to 1 over square root of 2, what will be x? X is going to be equal to, we come in this equation, x will be 1 over, where there is y in the denominator, we'll put 1 over square root of 2, because that is x value, that the y value that you found, meaning that x will be equal to square root of 2. And when x is negative 1 over 2, when y is equal to negative 1 over 2, x is going to be equal to 1 over, where there is y in the denominator here, we'll put now negative 1 over square root of 2, meaning that x is going to be equal to negative square root of 2. So this is this one. The binary operation star on the set of positive rational numbers is defined by x star y is absolute value of y minus x over 1 plus xy. Show that star is commutative. We know that x star y is equal to absolute value of y minus x divided by 1 plus xy. To show that it's commutative, we need also to find y star x. Y star x will just change, where there is x will put y, where there is y will put x. So that becomes absolute value of x minus y over 1 plus yx. Now, we know that absolute value of x minus y, I can also write it as absolute value. Let me factorize out a negative. So, the y which was negative will become positive inside there. The x which was supposed to become negative. In the denominator, we have 1 plus yx. Absolute value of 2 and absolute value of negative 2, they are all the same, it's 2. So absolute value of x minus 1 is the same as absolute value of absolute value of y minus x is the same as the absolute value of negative y minus x. And that will just be absolute value of y minus x. Okay. And then in the denominator we have 1 plus. Where there is 1 plus x, we can also say x plus 1 plus xy. We can say that this is the same as this, meaning that our operation is star. Star is commutative. So how do you conclude? Since x star y is equal to y star x, then the operation star is commutative. And then the next one, we want to evaluate 2 star 3 star 1. Every time you're evaluating binary operations, you always start with what is given in the brackets. So this is going to be 2 star. I'll first work what is in the brackets. So meaning that where there is x, we've substituted 3, where there is y, we've substituted 1. So that's what we'll be doing. That will be absolute value. Where there is x, we'll put, okay, so that will be absolute value. Where there is x, we'll put 1. Where there is y, where there is y, we'll put 1. Minus, where there is x, we'll put 3. Divided by 1 plus, where there is x, we are putting 3. Where there is y, we are putting 1. And this will be 2 star. 1 minus 3 is negative 2. Absolute value of negative 2 is a positive 2. The denominator 1 plus 3 is a 4. So this is 2 star half. So meaning now where we've reached here, the first term has now become 2. So where there's x, we'll be putting 2. Where there's y, we'll be putting 1 over 2. So this becomes, in the brackets where there is y, we'll put, in the absolute bar, we'll put half, minus where there is x, we'll put 2. This is in absolute bars, divided by 1 plus x, where there is x, we are putting 2, and it's multiplying with y, where there is y, we are putting 1 over 2. And this will give us half minus 1, that is going to be negative 3 over 4. Remember, it's in absolute bars. In the denominator, we are going to have 1 plus 2 times half is a 1. Absolute value of negative 3 over 4 is 3 over 4. Let me say divided by instead of over. And in the denominator, we have got a 2. So this is the same as 3 over 4. We can change this to times so that it becomes 1 over 2. And so this is a 3 over 8. Okay, so that is how you work out that one. Let f of x be equal to x squared minus x minus x by completing the square expressed in the form a x minus h squared plus k. Now I'll mention again, if you've been attending our classes, there is no exam that I've ever seen at UNZA that came and there was no completing the squares and sketching. So if you know what is good for you and you have got problems with completing the squares, make sure that you understand. So here, want to complete the squares. When you want to complete the squares, always make sure that the number in front of x squared is a 1. If it is not a 1, factorize out so that you make it a 1. But for this one, it's already a 1. So all you do is just get the first two terms here. Okay. I'll write x. I'll remove the power 2 minus. I'll get the number in front of x. The number in front of x is a 1. So that one, I'll take it half. The half of 1 is 1 over 2. This number, I'll write it in brackets and then square. Always put a minus here. This same number that was the half of the number in front of x, square it. So 1 over 2 squared will give you 1 over 4. This number, the whole of this term here is the same as this term from x squared minus x. It's the same as that term. At the end, you also have a minus 6. So this will be x minus 1 over 2 squared, negative 1 over 4 minus 6. To simplify things, put a 4 on top. Also put a 4 down. I've not changed anything. It's just easier to work with the same denominator. So just say negative 1 minus 24. That would be a 25. And then the common denominator is a 4. So I've completed the squares already. I've written in this form. Sketch the graph indicating the turning point x-intercepts. To be able to do that, I need to first find at least my intercept. So x-intercepts, where the graph is cutting the x-axis, happens when y is equal to 0. So come to this equation. x squared minus x equated to 0. The product here is negative 6. The sum is a negative 1. Two numbers to multiply, you get negative 6. You add, you get a negative 1. Should be a 3 and a 2, but the bigger number should be negative. So meaning that here, if we factorize, we're going to have x minus 3, then x plus 2. That will be equal to 0. And that x is going to be equal to positive 3, and x is going to be equal to negative 2. The y-intercept is always this constant we see here. So we can sketch our graph. We put our turning point. Our turning point will always be the number in front in the brackets, remove the sign, change the sign, 1 over 2. If it was positive, it would be negative 1 over 2. And then get the number outside the brackets. You don't change the sign, negative 25 over 4. Negative 25 over 4. 4 can go into 24 like 6 times. So this is basically 6 and a quarter. So this coordinate is 1 over 2. Say 1 over 2 is here. And then negative 6 and a quarter. Let's say negative 6 is here. So negative 6 and a quarter will be slightly just below. So it will be, the coordinate will be somewhere here. That will be the turning point. The x-intercept is negative 6. So the graph will be passing here. The graph is also passing at positive 3. Let's say positive 3 is here. And that negative 2, let's say negative 2 is here. So the graph is supposed to move like that. Come and pass here and go and pass there. Okay, something like that. Just make sure that you show this coordinate here as 1 over 2 comma negative 25 over 4. Find the numbers x and y whose difference is 10 and whose product is a minimum. Find two numbers x and y whose difference is 10. So I've got two numbers x and y. So x minus y, if you subtract these two numbers, they should give you their difference being 10. And whose product is minimum. So x times y should give you the minimum. Okay. Now such questions, all right. So whose product is minimum? So these two numbers, when you subtract them, the smaller one of these, that will be the minimum value. That will be their, not even that statement I want to mention. This statement is so interesting. Let me breathe first. So I've talked enough. I've talked a lot. Okay. All right. So let's analyze it now. These two numbers, when you subtract them, they'll give you a 10. When you multiply these two numbers, they are going to give you a minimum. I don't know what topic they wanted to apply, whether it's quadratics or something like that. But anyway, whatever they wanted us to apply, we don't know. But think of two numbers. Let me write it like this. Which will be giving you 10 when you subtract them. So let's say here we are having x, here we are having y. Okay, so let's say we have got 10 here. What should be the y value such that when we subtract we get a 10. So remember, their difference should give me a 10. So I need to have y being a 0. 10 minus 0 is going to give us a 10 there. If let's say we go to 11, it means you should be a 1. And still, if we subtract, this is going to give us a 10. If it's a 12, this is a 2. That is going to still be a 10. And just like that. But if you look at these numbers, if we subtracted here, the difference would be 11 here and then 10 minus 1. Hope you are getting what I'm doing. 10 minus this 1 here, this will give us a 9. 12 minus 0, this will give us a 12 here. 12 minus a 1 here, that is going to give us 11. And then 10 minus 2, that is going to give us 8. 11 minus 2, that is going to give us what? A 9. Okay, to continue to go like that. If we multiply the two numbers, the product should be minimum. The only two numbers which you can think of as at now, which you can subtract and you get the smallest number possible, is 10 and 0. Because 10 times 0 is 0, and there's nothing that will exceed 0 when you subtract two numbers and then they're giving you a 10. Hope that makes sense, because anything else of these, of course, 11 and 1, they are giving you a 10. If you multiply them, the answer that you are going to get will not be minimum, will not be smaller than when you use 10 and 0. So there are some topics like this where you are just applying some bit of common sense. You're not finding it anywhere. Okay. Sketch the graph of f of x, which is absolute value of x, plus absolute value of x minus 1. When you are sketching a radical which has got two radicals, what you do is you are going to redefine your function. Equate this one to 0, you are going to find that x is equal to 0. Equate this one also to 0, you are going to find that x is equal to a 1. Now get these two factors that you've equated to 0. So x is equal to 0. Look at the way the function will be behaving for values of x greater than 0 and for values of x less than 0 in the factor itself. If I get any number above 0, for example a 1, I put where there is x, I'll find a positive number. Anything below will give me a negative number if I substitute where there is x. And then for x minus 1, when I equated to 0, I found x to be positive 1. Any number that I'll get which is above 1, I put where there is x. For example, a 2, I'll get a positive number. Anything below will give me a negative number. So that is what you want to do. And then we can now go on and be redefining our function. So f of x, our interest is in writing numbers. Remember, our two critical points is x is equal to 0 and x is equal to 1. So I want to see how the function will be behaving for values of x greater than 1, values of x between 0 and 1, and values of x less than 1. So we have got three possible regions. So that's how we redefine this function. So I write x, I write plus, I write x minus 1. The absolute bars are not there. So let's say if this is for values of x less than 0 or less than or equal to 0, I write the factor again, x plus x minus 1. But let's say now this one is for values of x between 0 and 1. So say 0 is less than x and x is less than 1. We're just talking about values of x between 0 and 1. And then x plus x minus 1. Now want for values of x greater than 1. So these are the three regions. Now let's attach the signs according to how the function is behaving. Okay. According to how the function is behaving. To be able to see that, look at this. Let me now write these two factors all together. We have got x is equal to 0 and x is equal to 1. Remember, we had two factors that we had equated to 0. It was x and x minus 1. When we equated x to 0, we found a 0. We said any factor above 0, we put where there is x, it will give us a positive. Anything below 0 to give us a negative. When we equated x minus 1 to 0, we found a 1. Anything above 1 will give us a positive, and anything below will give us a negative. So we are now talking about values of x less than 0. You can see for values of x less than 0, x is supposed to be negative, X minus 1 is also supposed to be negative. So I'm going to attach a negative here and a negative here when x is less than 0. For values of x between 0 and 1, x is positive but x minus 1 is negative. So for x, I'll put a positive, x minus 1, I'll put a negative. Above 1, both factors are positive. Positive, positive. So this is what we just want to simplify. If I distribute the negative, so it's going to be negative x minus x plus 1, because this negative times x, negative times negative 1, positive 1. So negative x minus x, that will be negative 2x, and then plus 1. This is for x is less than or equal to 0. And then if I distribute the negative here, to be negative x plus 1. Positive x, which is here, minus x, it will be 0. Negative x times negative 1, that will be positive 1. So positive 1 for 0 is less than or equal to, for 0 is less than x, which is less than or equal to 1. And then if we use the positive, this will be positive x, this will be positive x. So that will give us positive 2x, and then that will be negative 1. This will be for x is greater than 1. So what we have done is I've just redefined the function. Now I can sketch it. Okay, so when sketching, we're only interested in our critical points. We have got 0 and a positive 1. For values of x smaller than 0, the equation that we are using is the first one. So try to get 0, you put where there is x. So the negative 2 times 0 plus 1, y is going to be 1. So the first coordinate is 0, comma 1, which is here. Remember, this one is only valid for values of x less than 0. Try to get a negative 1, it's also less than 0. You put where there is x. Negative 2 times negative 1 is a positive 2 plus 1 is a 3. So we are having negative 1, comma 3. This is another coordinate. This is the linear equation. Two points are enough. So this function will be going like that. Between 0 and 1, when x is 0, or when x is any number from 0 up to 1, the y value we are finding is 1. So as long as we are between 0 and 1, the y value is always 1. So we are getting a straight line here, like so. As long as we are between 0 and 1, the y value is always 1. Greater than 1, we are using this function. Get 1, you put where there's x. 2 times 1 minus 1 is giving us a 1, so that will be a coordinate. Try to get any number above 1, for example, a 2. When x is 2, what will be the y value? 2 times 2 is a 4, minus 1 is a 3. So we're getting 2, comma 3. So there should be a straight line. Just join using a ruler or anything. So that will be it. So this is the graph for this function. And the state is domain. Domain, I mean range. Domain is a set of values for which the function is defined. You can see it is going all the way to negative infinity, all the way to the positive infinity. So the domain is from negative infinity to positive infinity. But the range of this function, the y values for which the function is defined, the smallest y value we can have is 1. And then the function is going up. The biggest y value we can have is infinity. So this is going to be the function. Solve the following inequality expressing your answer in interval notation. X plus 6 over x plus 1 is less than 2. Always take to the other side, please. For inequalities, rational inequalities, you never cross multiply. Merge this as a single fraction, that is going to be x plus 6. Multiply the negative 2 with what is down, that will be negative 2x minus 2. Multiply the two denominators, x plus 1 less than 0. So this is going to give us, we add like terms, 6 minus 2 is a 4, x minus 2x is negative x. In the denominator, I've got x plus 1. That is less than 0. Just equate what is on top of the fraction to 0 and what is down also equate it to 0. If we equate what is on top to 0, 4 minus x to 0, you are going to find that x is equal to 4. What is down equated to 0, x plus 1 is equal to 0. We're going to find that x is equal to negative 1. So I'll write these two values on a number line. I've got negative 1 and a positive 4. Look at the factors that we equated to 0. We equated to 0, 4 minus x, and then we also equated to 0, x plus 1. So when we equated 4 minus x to 0, we found 4. 4 is going to be the point where signs are going to be changing for that factor. If we get values above 4, for example, a 5, 4 minus 5 is negative. Immediately we cross 4 for that factor to be positive. Get any number less than 4, for example, negative 5. 4 minus negative 5 is positive. When we equated x plus 1 to 0, we found negative 1. Negative 1 will be a point of transition of signs for that factor. Get, let's say, for example, a 2. 2 plus 1 is positive. Immediately you cross negative 1, it will be negative. Now these two factors we are dividing, so we are interested in the quotient. Negative, positive, it will be negative. Positive over positive is positive. Positive over negative is negative. But for this equation, we are interested where x is less than 0. Less than 0 means where it's negative. So from here going this direction, and then from here going to this direction. So therefore the solution set in interval notation is going to be from negative infinity to negative 1, and then from 4 to infinity. So that is going to be that one. Now we'll go on with part 2. Given that 4x squared minus 4x plus 1 is positive for all values of x, find the range of possible values of k. Now I want to find the range of possible values of k. The only way a quadratic will give you positive is when what is inside is greater than 0. B squared, what is inside the root, b squared minus 4ac is greater than 0. Okay, because this is positive. So b here is the number in front of x, that is a negative k. So negative k squared minus 4a is 4. The number in front of x squared. C is a 1. Should be greater than 0, meaning negative k squared is positive k squared. Negative 4 times negative times 4, that is negative 16. Should be greater than 0. This is the same as k minus 4. K plus 4 is greater than 0. Equate this one to 0, going to find that k is equal to 4. Equate this one to 0, going to find that k is equal to negative 4. This is not an equation, it's an inequation, so I want to find the range. So I'll put negative 4 here, I'll put 4 here. I'll put the factors that are equated to 0 for me to find those. So I'm going to get k minus 4, then k plus 4. When I equated k minus 4 to 0, I found 4. If I get any value above 4, like a 5, I put where there is k, it will be positive. Below, it will be negative. When I equated k plus 4 to 0, I found negative 4. Anything above negative 4, for example, a 5, put where there is k to be positive. Anything below will be negative. These two factors we are multiplying, so I'm interested in the product. So negative negative is positive, positive negative is negative, positive positive is positive. I'm interested where the factors, the function is greater than 0, meaning that where it is positive. So meaning that for this one, the range is going to be from negative infinity to negative 4 union from 4 to infinity. Would have said greater than or equal to 0, but 0 itself is 0 positive. So 0 doesn't have any sign. That's why we are only saying greater than here. Okay. So from question 4, we are going to do this part in the next class. I think we have talked about a lot. So question 4 and the others will do them in the next part.